Hello students, in today's class let us continue with the last exercise 6.6 of chapter triangles. So sixth question, it is given that ABCD is a parallelogram and they asked you to prove sum of the squares of the sides is equals to sum of the squares of its diagonals. That is AB square plus BC square plus CD square plus DA square is equals to AC square plus BD square. So what are we going to do here is, let us draw perpendiculars from D to AB and A to DC in the extended side, right? Now we will repeatedly apply our Pythagoras theorem. Now first we are going to apply Pythagoras theorem for the triangle AFD, right? Pythagoras theorem for the triangle AFD. So what you will get in triangle AFD, by Pythagoras theorem, AD square is equals to AF square plus FD square, right? Mark this as 1. Now let us take triangle AFC, right? In triangle AFC, what you will get? AC square. AC square is equals to AF square plus FC square, AF square plus FC square. Now this AF square I can write it as AF square, I can write it as AD square minus FD square, AD square minus FD square plus this FC square we can write it as FD plus DC the whole square, FD plus DC the whole square. Why are we replacing all these things? Because AF we don't know, we don't need actually, which is outside of our parallelogram, and FC, in the part of FC, FD is also outside of our parallelogram. So we need DC AD only. So we are replacing AF in terms of AD and DC, part of parallelograms, right? Now expand this, what we will get? AD square minus FD square plus, expand this using A plus B the whole square identity, FD square plus DC square plus 2FD DC. Now plus FD square minus FD square will get cancelled. So which is AD square plus DC square plus 2FD into DC, right? Let it be one side. Mark this as 2. Similarly, now let us apply Pythagoras theorem for this triangle ADE and this triangle this triangle, okay, ABDE, right? Now let us apply Pythagoras theorem for those two triangles and we obtain the similar kind of relations. So in triangle ADE, what we infer? In triangle ADE, AD square is equals to DE square plus AE square. Mark this as 3. Now in triangle BED, BD square is equals to DE square plus EB square. Again, EB is a part of a side, right? So this EB can be written as AB minus AE. DE square plus EB can be written as AB. We need the full side. So AB minus AE. AB minus AE the whole square. Don't blindly write AB square minus AE square. We are replacing EB by AB minus AE. It has square, so it should be the whole square, which is equals to DE square plus AB square plus AE square plus 2ABAE, right? And this is BD square. Mark this as 4, right? Now what are all the equations we got so far? And before we get into that, let us do one more thing here. Since it's a parallelogram, we know AB is equals to DC. Since ABCD is a parallelogram, we know opposite sides are equal. AB is equal to DC and AD is equals to BC. Okay, and also in triangle ADE and triangle ADF, what you know about these two triangles? See, A angle ADE is equals to angle AFD, which is equals to 90 degree by our construction, right? And AD is the common side. AD is the common side, which is our common side. And we know parallelogram opposite sides are parallel. So what about this angle and this angle? They are equal since alternate angles are equal. Therefore, angle FDA is equals to angle DAE since alternate angles are equal. So we got A, yes, A, right? Therefore, by AAS, when we have two angle and one side, it is not necessary it should be a included side. Therefore, by AAS congruency criteria, triangle ADE is congruent to which triangle? D should correspond to F, right? ADE equals to AFD. So which are the angles corresponds? D corresponds to ADF. So this implies triangle ADE is congruent to triangle DAF. So this implies by CPCT all its congruent corresponding paths are equal. So AE will be equal to FD. FD will be equal to AE. This is what we need. Why? Because FD is a part of a parallelogram, outside of a parallelogram. We need in terms of its side. Then only we can prove our thing. So that's why we proved FD is same as AE. Now what we will do, we apply all these known results in the four equations. We will add it. Then we will get our answer. Now what are we going to do? We are going to add the second and the fourth equation. Why are we going to add second and the fourth equation? Because second equation what we got is in terms of AC square. AC square is your one diagonal, BD square is your another diagonal. So we are going to add our second and the fourth equation, sum of the diagonals. See, we got our third equation is AC square equal to AD square plus DC square plus 2FD DC. That's what we got. And our fourth equation is this. Now we are going to add these two. So what will happen? AD square plus DC square plus DE square plus AB square plus AE square plus this and minus this, right? Again, in terms of DE, we might have substituted in this place itself, but we failed to do it, so we are doing it here. Okay, DE square, DE is this triangle, what we got in our third equation. DE square can be written as AD square minus AE square, right? AD square minus AE square plus and the remaining terms. Again, if you see this FD into DC, FD is equals to what? AE. So FD I have replaced it with AE. And DC is the parallel side. DC is one of the sides of a parallelogram, so that can be replaced with its opposite side AB. So DC ke badla I have written AB, right? So we have plus 2 AEAB minus 2 AEAB. So these two will get cancelled, right? These two terms will get cancelled. So what we have here, AD square plus DC square plus AB square plus AD square minus AE square plus AE square. Again these two will get cancelled. So AB square plus, and again we have 2 AD square. So instead of 1 AD we can replace it with BC because those two are opposite sides. So AB square plus BC square plus CD square plus AD square. We have replaced 1 AD square as BC square since these are equal, opposite sides of a parallelogram. Thus we proved. We have proved the sum of the squares of the diagonals is equals to sum of the squares of its sides. Yes, hope you understood. Very easy proof. What we have done here, only if you remember the construction, what we have constructed, we have dropped perpendiculars, that's it. Then we have repeatedly applied the Pythagoras theorem for the 4 triangles, and we tried to replace the part of the parallelogram which is out of it by the part of the parallelogram itself, right? Wherever we got AF, FD and all, we have replaced it with the parts of the parallelogram, required parallelogram. Then we tried to prove the congruency of these 2 triangles in order to tell FD is same as AE. So if we have FD, we can replace it with AE. Then with the repeated simplification, we arrived at our answer. Yes, hope you understood. Now let us see how can we solve our 7th question. It is given AB and CD are 2 chords intersect at P. We need to prove that triangle APC, this triangle, is similar to triangle DPB. This triangle we need to prove. We need to prove these 2 triangles are similar. So in order to prove 2 triangles are similar, what we need? We need minimum of 2 angles, right? Or else corresponding sides should be in proportion. Now let us check for its angle. When we see a diagram like this, immediately which will strike our mind? The vertically opposite angles are equal. So we got one angle. If we have one more angle, automatically the 2 triangles will become similar. What is the another angle where we can find out? Think it can be easily arrived. What is the another angle? The another angle is this. If you join C and B, CB is a chord, right? Angle made in the same segment are equal, right? So see, the angle CAB is angle made by the chord in the same segment, angle A and angle D. Yes or no? Angle A is made by the chord CB in the segment, and angle D is also angle made by the same chord CB in the same segment. This is the angle made by the chord CB and this is the angle made by the chord CB in the same segment. Therefore, angle A will be equal to angle D, right? So, we got 2 angles equal. Therefore, by AA similarity criteria, these 2 triangles will become similar. When 2 triangles are similar, automatically the corresponding sides will be in proportion. So, you will easily arrive at this result. Instead of giving it as a ratio, they have given it as a product, so you have to cross multiply it, right? So solve this problem, present it neatly. I have given you the entire clue to solve the problem. Let us move on to our next question. Here again AB and CD are 2 chords. We need to prove triangle PAC. This triangle is similar to triangle PDB, which means the entire triangle, right? How will you prove these 2 triangles are similar? Immediately we got one angle. What is it? Angle P. Angle P is common for both the triangles. So if we have one more angle again, the 2 triangles will become similar. What is that angle? How will you find out? What can you infer from this ABCD? ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. What is the property you know about cyclic quadrilateral? We learnt in class 9. What is it? Opposite angles will be supplementary. Opposite angles are supplementary. Opposite angles are supplementary, which means angle C plus angle B is equal to 180 degree, angle A plus angle D equal to 180 degree. But what can we do with that? But this property implies exterior angle will be equal to opposite interior angle. This property implies this. How? If angle C equals to angle B, angle C equals to angle B, this implies opposite angles are supplementary. So angle C plus angle B equal to 180 degree. I am extremely sorry. Angle C plus angle B equal to 180 degree. Opposite angles are supplementary. Similarly, angle A plus angle D is 180 degree. But if this is angle C plus angle B is 180, right? And what about this plus this? That is also 180 because angle on a straight line. This is your exterior angle, right? So exterior angle C plus angle C is also 180 degree by angle on a straight line, right? Because angle on a straight line. So from these two, what you infer? Angle C is equals to angle C, 180, 180. Therefore, angle B should be equal to exterior angle C. Angle B is equals to exterior angle C. So that's what the property says. Exterior angle is equal to the opposite interior angle. How we arrive at? By the property, opposite angles are supplementary in a cyclic quadrilateral. Therefore, this angle will become equal to this angle. Right, this angle will be equal to this angle. So we got two angles again. Angle P is common and angle ACP is equals to angle ABD. Check out the correspondence of these vertices in the given condition. See, in the place of P we have P, and in the place of C we should have B. C, B. Yes, we got it. Therefore, by AA similarity criteria, these two triangles will become similar, and obviously the criteria will follow since corresponding sides are in proportion. Again, it is given in product, you will get in ratio, cross multiply, you will arrive at the solution. Okay, so I am leaving 7th and 8th problem to you. You can very well solve it. I can given you the entire clue for the problem, right? Let us move on to the next question. Now let us see how can we solve our 9th question. It is given BD by CD is equals to AB by AC. They asked you to prove AD is the bisector of angle BAC, which means this angle is equal to this angle. That's what we need to prove. So we have done the problem of same kind in the converse in the previous exercise. Hope you remember. So the same procedure we are going to follow here, the reverse steps of that same problem. So what are we doing here? We are going to extend the side AB to P such that AC is equals to AP. In such a way we are constructing. Now join PC. Right. Now what is given in the question? BD by CD is equals to AB by AC is given. AB by AC is given. So instead of AC we are going to replace it with AC. So this implies BD by CD is equals to AB by AP, since AC is equals to AP by our construction. Now what we got? BD by CD is equals to AB by AP. Therefore, by converse of BPT, what we know? By converse of basic proportionality theorem, we have AD parallel to PC, right? AD parallel to PC. So what about this angle and this angle will be equal because these two are corresponding angles. Considering the AD and PC as our parallel lines and AP as our transversal, this angle will be equal to this angle since these two angles are corresponding angles. So this implies angle BAD will be equal to angle APC. Since corresponding angles are equal, right? And similarly, what about this angle and this angle? This angle and this angle will be equal because considering AC as our transversal, AD and PC are parallel lines. If you consider AC as your transversal, these two angles will be equal since alternate angles are equal. So how will you write? Angle DAC will be equal to angle ACP since alternate angles are equal. You should know which line is considered as a transversal. But already this angle is equal to this angle. How? Because these two sides are equal, therefore this will become an isosceles triangle. In an isosceles triangle, base angles will be equal, right? So this angle will be equal to this angle and hence these two will become equal. So how will you write? But angle APC will be equals to angle ACP since AP is equal to AC. So this implies angle BAD is equals to angle DAC. Hence, AD is the bisector of angle A. That's what we need to prove. Right? Hope you understood. Let us move on to our last question now. Now let us solve our last problem. What is given in the question? Nazima is fly fishing in a stream. The tip of her fishing rod is 1.8 meter above the surface of the water. So tip of a shipping rod is 1.8 meter above the surface of the water, and the fly at the end of the string rests on water 3.6 meter away. So the distance from here to Nazima is 3.6 meter and 2.4 meter from a point directly under the tip of the rod. So they are telling that the fly is exactly 2.4 meter away from the from here, right? Directly under the tip of the rod, So the total distance of the fly from here to here is 3.6 meter, whereas from here to here is 2.4 meter. So this distance will be 1.2 meter. 3.6 minus 2.4, which is 1.2 meter. Assuming that her string is taut, in the sense it is exactly straight, tight. How much string does she have out? In the sense we need to find AC, right? This is our first question. To find AC is our first question. The second question is, if she pulls in the string at the rate of 5 centimeter per second, what will be the horizontal distance of the fly from her after 12 seconds? So what is given? Every second she is pulling her string 5 centimeter. Every second after fishing it, what they will do? They will unroll the string, right? So for every second she is pulling 5 centimeter of the string. If that is the case, after 12 seconds where this fly will be? It will move back, right? So in that case we need to find the horizontal distance from the fly to Nazima. That's what we need to find. First let us find what is the length of AC. That can be easily find out because this triangle is a right triangle. So applying Pythagoras theorem we can find what is our AC, right? So first let us find what is our AC. AC square is equals to AB square plus BC square. So applying Pythagoras theorem we got the measurement of AC as 3 meter. So we found this first. And they asked you to find out what is the horizontal distance of the fly. Horizontal distance of the fly from Nazima if she pulls a string 5 centimeter per second. That's what the question, right? So if she pulls, see actually the string is this, the string's length is 3 meter. She pulls a string back 5 centimeter for every second, and they asked after 12 seconds. So if she pulls 5 centimeter per second, then after 12 seconds, how much centimeter of the string will be pulled in actually. So it is 12 into 5, which is 60 centimeter. All others are in meter. So convert into meter, which is going to be 0.6 meter of the string. So 0.6 meter of the string has been pulled in. Therefore, the length of the string, see after pulling out the string will come near to Nazima, right? So the length of AD, how much it will be? From 3 meter, 0.6 meter you have to reduce. Therefore, the length of the string will be right now 2.4 meter. 3 minus 0.6. Now the string has come here, therefore the fly is in the position of D, right? Now they asked you to find the horizontal distance of the fly from Nazima. So this distance we need to find. Already we know the distance from B to Nazima. B to Nazima is 1.2 meter. Now we need to find what is BD, right? If we find BD, we can add these two to find the horizontal distance of the fly. Now how will you find this BD in triangle ABD, right angle triangle? Again, BD square can be obtained by AD square minus AB square, right? We know both the distance. This is 1.8 and this is 2.4. If you apply Pythagoras theorem and take the square root, we got 1.587 and add this is 1.2, that will give you the horizontal distance of the fly after 12 seconds. Yes, hope you understood. So with this we will wind up today's class and hence the chapter as well, triangles. So with this we are completing the chapter. You may find it vague or difficult, but if we practice more problems you will get familiarized with this. Let us move on to the next chapter. So while we are revising, I will give you more additional practice problems on this chapter so that you will get familiarized with that, right? Do these two problems as homework and go through the entire chapter, each and every problem right from concept 1 of this chapter. And if you have any doubts, you can ask me. Thank you, students.